This is my other favorite method for finding GCD and LCM, and that's using the Venn diagrams method. I'm a very visual learner, kind of a hands-on learner, and I like having a picture to refer to. So let me show you how you can do this with Venn diagrams. If you want to find the GCD and the LCM of two numbers, the first thing you want to do is consider the prime factorization of each number. So to save time, I went ahead and did the factor trees over on the side for 12 and 30. Two little cute factor trees, and I wrote out their prime factorizations. Remember, you always put multiplication symbols between, and you go from low to high. That's the best way to write these. So if I want to arrange the factors of 12 in the left circle and the factors of 30 in the right circle, well, then what I need to do is I need to consider which factors would go in the intersection and then which ones would not be in the intersection. So if we look for the common factors are, they have a 2 in common, so I can put 2 here. And they also have a 3 in common, so I can put 3 in the intersection like that. So first identify the intersection, the 2 and the 3, and then look at any leftovers. So 12 also has a 2. So I've got a 2 and a 3, but I have another 2. You write it over here. You don't boot it out of the picture. It's just in the left circle, not in the intersection. And then 30 has a 2 and a 3, but it also has a 5, so you need to put a 5 over here. So you can see if you cover up the factors of 12, and you can see the factors of 30. So the GCD is what it has always been, which is just the common factors. So the GCD is going to be this part right here. The GCD is the intersection of the two sets. So the GCD in this case is going to be 2 times 3, which is 6. So the greatest common divisor is 6. Okay. For the LCM, you would take the common factors, but then you would also take the leftovers. So if we use the what we've got here in the intersection, but then we also include the leftovers, then basically what we're getting is both circles all together, a 2, a 2, a 3, and a 5. Well, that's a union. So the LCM is the union of the two sets. So the LCM would be 2 times 2 times 3 times 5. Notice these in the middle are the common ones. And if you multiply all that together, you get 60. So it turns out that the LCM is 60. So the LCM is the union, the GCD is just the intersection. And so this ties this back to the previous chapter when we talked about Venn diagrams. You need to know how to do one of these for sure. So let's try another example. We're going to do GCD of 24 and 60 and the LCM of 24 and 60. So those are our two numbers, 24 and 60. I'll put factors of 24 in the left circle, and I'll put factors of 60 in the right circle. But we've got to do some factor tree first. So 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So there's 24. 2 times 2 times 2 times 3. For 60, that's 6 times 10. 6 is 2 times 3. 10 is 2 times 5. It's a pretty short tree there. So for 60, make sure you put them in order from low to high. 2 times 2 times 3 times 5. Okay, so the first thing you do is look to see the ones that are common, the ones that would be in the intersection, and that would be a 2, and then another 2, and a 3. Just list them like that. List them separately. 2, 2, 3. Now 24 has a 2, a 2, a 3, and then there, see this leftover 2? You got to fit him in the picture. And on 60 there's a leftover 5. You got to fit him in the picture. So the GCD of 24 and 60 is going to be the intersection right here. 2 times 2 times 3. Those common factors, when you multiply that, you get 12. That would be your GCD. The LCM of 24 and 60 would be the union. So all of the numbers that I just circled. So 2, 2, 2, 3, and 5. Again, those are the common ones there in the middle. And if you multiply all of that together, you should get 120. So the Venn diagrams method I like also because it's like one-stop shopping, right? You do the one method and you're able to pull the GCD and the LCM from it. Plus you can also see it on paper, and if you're visual, then you might like the layout here.